I'm going to talk about soil health in high tunnels and just a little background on me. So I've been working in tunnels for a little over 10 years now. We got our first high tunnels at the UK Organic Research Farm, or at the Organic Farm, which is about 10 acres subset of our Horticulture Research Farm in Lexington. Got those in about 2011, and we set them up. I had come from doing my graduate work down at the University of Georgia, where I worked with a lot of farmers who had been selling into Atlanta and getting pretty good prices for a lot of years. And they were starting to see soil health issues in their high tunnels. So when I came to Kentucky, we didn't have a lot of tunnels on the farm, and the NRCS program was just starting. And so it seemed like a good time to set up a system that maybe we could say something about, and maybe a decade later. And so you can see here we have 10, let me see if I can get this right. I don't know. I'm terrible with the pointer. It's a good thing I have long arms. I may just walk over there. So we have 3 stationary high tunnels and 3 movable high tunnels that we designed and built ourselves. So I'm not going to talk a ton about the movable tunnels within the talk, but if y'all have questions about them, I'd be happy to talk about them. I think we've made every possible mistake you can with movable high tunnels, and we finally now have something that we like and we think is reasonable in terms of labor and things like that. So happy to talk about those, but I'm going to focus a little bit more on what we've been working on with regards to learning more about soil processes, managing soil fertility, and some of the issues that come up with that, and things of that nature. Just so I can get a quick vibe check of who's here, how many folks currently have a tunnel? Oh my goodness, okay. How many people have had that tunnel for under 3 years? Ooh, okay, experience. Okay, how many people under 5 years? Under 5 years. Okay, how many people have, so then how many people have had a tunnel for 5 years or more? Okay, awesome. So you are also you all will probably have a lot of questions, and will be able to see some of the trends that I'm gonna talk about. This is excellent. How many folks are growing for auctions in their tunnels? Hardly anybody. Direct market? Selling farmers market, things like that? Okay, great. That's awesome. That lets me know a little bit about your diversification and scale and things like that. Y'all just feel free to interrupt me anywhere along the way, okay? If you have any questions, or if I can help tweak this to something that's gonna be more helpful for you. In particular, so I've done a lot of work on cover crops in high tunnels over the years, things like greenhouse gas emissions, nitrogen cycling, that kind of stuff. But what I want to talk about today is some new efforts that we have in trying to figure out what's going on with high tunnels, really across more than just Kentucky, but across the eastern United States. So I'm going to talk about a project where I have partners, and I'll mention who they are in a little bit, in all these states here. So basically east of the Rocky Mountains. We got 10 or 11 states involved, a bunch of great folks, and we're trying to figure out the things that are unique to our soil health problems in our various states and regions, and the things that are the same regardless of where you go, and how we have applied research and some of the key issues that are emerging there. And so what you see here with all these numbers, so we worked with the US, with the NRCS headquarters in DC to get these numbers. These data sets don't really exist out there. They're publicly available, but they've not been published. These are the most recent numbers on the number of high tunnels just funded under the NRCS program since they started it in 2010. So over 26,000 high tunnels across the United States. It's $170 million in federal investment. Okay, so the government has a lot of money tied up in high tunnels. And that doesn't count all the tunnels that y'all have that maybe weren't paid for by the government. But we have no way to count those other ones. They're not measured on the ag census or anything like that. So this is the only, we know it's a really low ball number, but it's the only number that we really have. But it does represent a pretty significant investment. And what's really interesting, if you feel like high tunnels are popping up all over Kentucky, it's because they are. We have the greatest investment of any state EQIP program in the country, and we were late adopters to the tunnel program, so it's really changing the landscape of what we're doing here in the state. So I'm going to talk about some of the work that we're doing as part of some regional and then these like multi-regional projects, and the things that we're learning. In particular, project team from everybody that was in that previous slide, folks kind of all up and down the eastern seaboard and all the way west to Kansas. So a mix of horticulture folks, economists, soil scientists, those kinds of things. So big team. And I put this up here, not because you're going to know any of these folks, but just so that you know, if I reference somebody's name offhand or something like that, some of the stuff that I'm talking about is things that we've discovered as a group through our conversations and through farmers that we've interviewed and things like that. So it's not my work, it's just so you know, it's kind of the work of a team. We also have a whole bunch of awesome project advisors on here, rock star farmers from kind of up and down the East Coast, folks involved at NRCS, at state and national and regional levels, industry, nonprofits, beginning farmers, organic folks, non-organic folks, kind of all across the board. So I'm going to tell you kind of how we got some of the information and some of these trends and things that I talked about through this kind of year and a half long planning process. So, but I also want to talk about what I mean by soil health relative to high tunnels. We had a NRCS person on our advisory board that said, soil health, you can't have that in a high tunnel. There's no such thing. It's not the way we treat our tunnels. The soil is not healthy. It's essentially greenhouse media. So I was like, okay, I can see where he's coming from on that. So when we talk specifically about soil health, we frame it in the way that a lot of producers do and what we heard from producers. And things, when we think about kind of the biological elements of soil health, thinking about things like earthworms, there's a lot of questions about microbial processes in soils, in tunnels, especially in organic systems, where we rely on them to provide fertility to our crops. We talk about, usually you see this as the chemical pillar or the chemical side of soil health. We're pretty much just talking about nutrient management, okay, right, for crops. And then from a physical properties perspective, it's pretty much compaction, okay? That's the biggie that we think about. So to some extent, soil aggregation and stuff like that. But I want to be clear that I am talking about soil health from chemical, physical, and biological perspectives, but it's kind of tweaked for these really intensive systems. So basically, you can see we did a whole bunch of work over the past 2 years, interviewed about 30 farmers that I'm going to talk about, did really comprehensive literature review, reviewed like 70 academic publications, 50 extension publications, or writing review paper, talked to tons and tons of people working with tunnels, all over the United States, multi-day meetings to basically bring all this information together. I'm going to give you all the highlights today. That's the only reason that I'm kind of belaboring all this stuff here. And key in the things that I'm going to talk about today are the things that producers told our group. So we interviewed producers in regions all around the U.S. We did this over Zoom, and so we had a half dozen growers in New England that joined us for a focus group, about 7 in the Great Lakes, about 10 in our neck of the woods, and then about 7 in the Deep South. And we interviewed these folks in focus groups and in case studies, doing a deep dive with some really experienced producers to just figure out what problems that they've had, how they overcame those problems, and if they didn't have problems that are kind of common that I'll talk about, what were they doing different? How are these really successful people kind of making it in the long term in these really disturbed kind of soils? Not all of them were organic, but they were pretty representative of the region. So almost everybody we talked to in New England and Northeast were organic, and that's most of their producers in tunnels are organic. From talking to the extension specialists up there, about half in our region and about half in the Deep South. So a lot of this is applicable to us directly as organic producers. So let's just do a little level set on why sustaining soil health in high tunnels is hard, okay? We've heard that soils are meant to be covered, right? But usually we're talking about cover crops when we're talking about that. We're not talking about covering them in plastic with a big umbrella, okay? So that's kind of the fundamental, one of the fundamental issues with high tunnels, right? Soils evolved to have rain and the elements on them. So it's a huge benefit to us from the production side to not have rain splashing on the leaves of our crops or splashing on the soil and then splashing up onto the leaves of the plant. But it also creates a really different environment. Some people call high tunnel soils irrigated deserts or a humid desert. Because as you know, if you don't water in there, it's bone dry. We also, really pretty tillage intensive in tunnels. We irrigate, but we don't ever have any natural rainfall in there, providing flood events, pushing nutrients down, things like that. And we tend to be pretty limited in our crop rotation. I love this quote from one of the organic producers in the Deep South that we interviewed, and she had said, Organic growers are religious about what they do outside, and then we abandon all of that in tunnels because the space is so valuable. We abandon all of our principles. Of course I'm having problems. I've abandoned all the things I've been taught not to do. And she has, I mean, probably 20 tunnels, a couple heated greenhouses, been growing in soil for a better part of 15 years and is running into trouble, and she's kicking herself now. But she's, you know, kind of like, well, of course I should have seen this coming. And she's working on it, but she would have liked to avoid those problems in the first place. So that's what we're trying to help figure out how to do. So today we're going to talk a little bit about kind of challenges, best practices that we picked up from this work, gaps in knowledge that we have, especially related to soil organic matter management, nutrient management, irrigation management, and then whatever you all have questions about or we want to talk about. Let's just talk about, we'll start by talking about soil organic matter management. And we know soil organic matter is depleted by things like tillage, right? Busting open soil aggregates and oxidizing all that material inside those aggregates tends to break it down. It's also warmer in there. It's wetter. We don't tend to take time off quite as much. We don't tend to cover crop, all of those things. There's more nitrogen and nutrients in the soil. So all of this is speeding decomposition rates inside of tunnels. So it makes it pretty hard to maintain our soil organic matter. But we have a few options, right? So many of us go to compost. And the reason for that is that cover crops can be tricky, right? So tricky to work in the rotation. But what we're finding is that it may be an important tool in the toolbox, although it may look different depending on where you are. So I'm going to start by talking a little bit about compost, and then we can get a little bit into the cover crops. I'm going to kind of do a flyover of the things that we've learned from folks. But if y'all have any specific questions, you know, I think we've played with every iteration of cover crop you can in our tunnels over the years. I'd be happy to talk to you about tips and tricks and things. You know, a lot of times when we talk about managing compost in the open field, especially in Kentucky, where we have a lot of the state has phosphatic limestone basin or parent material, we talk about, like, don't apply compost. We need to get organic producers to think about less compost and those kinds of things because of the phosphorus load that comes along with it. Because we don't tend to need it, right? If you've ever taken a soil test, most of the time our phosphorus is plenty high. And so when you add compost, you're often adding a lot more. So when you're applying compost in the open field and you have quite a bit of phosphorus, the problem is there that'll run off into waterways and be polluting and things like that. Well, we don't have that problem necessarily in tunnels, right? We don't have the erosion that we have in the open field. We also have folks using compost at pretty high levels. So where you might apply a 1/4 inch in the open field, you might apply an inch or 2 in a tunnel. So we do tend to see buildup of phosphorus, but the environmental impacts are not the same as they are in the open field. And we're also seeing phosphorus levels that are like astronomically higher than what we ever see in the open field. But we're not seeing production problems. So folks we're basically, the extension and even soil testing companies will tell you don't apply phosphorus, you have tons, but then you apply a little more compost and you're still fine. This is a question. We do not know what is going on here, but we know it's less of an environmental risk than it is in the open field. So all of this to say, I'm not going to be militant about don't apply compost ever, because we have some limited tools for organic matter management, but we need to be mindful of the implications of what compost use does for us. Beyond the environmental side of things, it does super weird things to your nutrient cycling. Okay, so we'll talk about that in a minute. It affects your fertilizer and maybe even how you should soil test, okay? And we also know, sometimes people say compost is a long-term fertilizer that you apply. What we're finding in the literature and things that we're seeing in our own research is that you really only see a nitrogen bump from that compost really for about the first year. It's not 2, it's not necessarily 3 years. It's moving real fast. So if you're using compost as nitrogen-based fertility, you might want to be using something in addition to that. Don't necessarily think, oh, that doesn't mean apply more compost next year. It means that it's not a long-term fertilizer, and you may want to be thinking about some other sources. And then the last piece here, and we're going to get more into this, is that when you start talking about having soil organic matter percentages of 10, 15%, we see those in high tunnels, your soil's starting to behave more like soil in a pot. Soil that is greenhouse media in terms of the way nutrients exchange. And so the soil tests that we're running are not going to be as useful to you because the nutrients aren't behaving in the same way. So all of this to say, if you've been applying a half an inch or whatever of compost to your tunnel every year, or you have really, really high organic matter levels, let's talk about some different ways that you may want to test your soil, because the soil, if you're not getting great results from your soil test, there's some reasons for that, and some of it is you might not be using the right test. Okay, so then I'm going to talk a little bit about cover crops. And like we talked about, cover crops are hard to get right. We'll talk about maybe some opportunities for different types of windows of cover crops. But cover crops can also be a really useful tool in organic matter management in tunnels. And a lot of times legumes get the glory in the open field for thinking about bringing in free nitrogen, right? Well, nitrogen is the least of our input costs in a tunnel, right? It's labor and all of the other things that go along with it. So I think the argument for nitrogen benefits out of legume cover crops is not a real strong selling point for them in tunnels. However, we do see that they really help sequester carbon in tunnels as well, whether it's used in combination with a compost or a manure or something like that, or just on their own. So even if you're using a legume, because it breaks down fast or something like that, you can still see a carbon benefit. There's not as much research being done on grass cover crops in high tunnels. It's an emerging area. There's some work coming out in different parts of the country, but the management challenge there is you got to find time to grow it, and it takes a lot longer to decompose than that legume. So that's something I would say that we're really on the front end of trying to work out. This data here, I should talk about that for a minute. So this is from a study that we did, University of Minnesota, Kentucky, and then Kansas State. The gentleman who runs hightunnels.org was involved in this as well, Dr. Kerry Rivard. And what we found we didn't find it in Kentucky because they wanted us to use winter cover crops, which I'm like, not a great choice for us. I'm editorializing here, but we had to go along with what the people in the cooler climates wanted, and they wanted a winter cover crop. So we grew hairy vetch, and what we found in those cooler climates is that the vetch did a good job providing a good nitrogen benefit. In Minnesota, they only had to apply half the amount of nitrogen, but the kicker here is that they were also able to sequester carbon, at least in terms of the active carbon pool that we looked at there. So it can be a good tool for carbon management. And really, for any cover crop, if you've not, how many people are cover cropping currently? Oh my gosh, what? I don't have to, I'm so glad I asked that, because now we don't have to make the sale for cover crops. So what I want to do is make a pitch for summer cover crops. How many people are winter cover cropping? Okay. How many people are summer cover cropping? Okay, so hang with me here. I'm gonna try to convert at least some folks to thinking about summer cover crops, because I feel like, depends on your market, but they can be a really good choice here. And this is consistent with what we found producers were telling us around the country as well. Successful producers who had been working through soil health management challenges and those kinds of things. Folks who were not reporting massive problems, things being kind of all over the place, were kind of consistent cover croppers. They didn't let the perfect be the enemy of the good. They weren't trying to necessarily grow the highest biomass cover crop. It was the consistent story of, well, I try to get it in there once a year, if not two. Once a year or once every other year sometimes. I'm doing the best I can, but I'm getting it in there. And it was a lot of the organic producers. And, they would sometimes beat themselves up and say, I don't get as nice a stand as I do in the field. I wish I could let it go longer. But the folks that were consistently incorporating cover crops, of these 30-plus producers that we talked to, had less problems with disease management. They tended to have less salt buildup. And it may be because, for example, they're keeping stuff growing and they're keeping the water on. So the soils are constantly, ideally, moving some of those salts down and things like that. So folks that were more proactive on that, on the cover cropping end, it appears to be somewhat of a good preventative strategy. Mechanism-wise, we don't know. I couldn't tell you the best place. If you always put a cover crop and water it this way, it's going to help you never have a salt problem. We can't really say that. But it does appear to be a pretty good preventative strategy. When we saw some folks adopting cover crops is when they have a particular management problem. So for folks in the deep south or on real sandy soils up north, they've started to have nematode problems in their tunnels. Getting a non-host crop in there and trying to use some of the some of the nematocidal compounds in certain cover crops, or just having them be non-hosts, things like certain varieties of sun hemp and stuff like that. They were kind of late adopters to cover crop. Not to say that it doesn't work. it does appear to be efficacious or helpful in the cases of some of these problems, but it tends not to be a silver bullet. It tends to be a good tool in the toolbox for things like nematode management and things like that. But all of this to say, a cover crop's not going to fix a problem on the back end, but they may help you avoid problems on the front end, okay? And when it works, really kind of depends on your window of your most important crops, right? So it's great if you can take time off a cash crop to cover crop, but that's not the reality, right? And so when does it fit in best? So a lot of the research around the country has been done with winter cover crops in high tunnels, especially here and further south. That's our prime growing time, right? And so we've been doing some work with folks in the southern region looking at warm season cover crop strategies. So with our winter cover crops, yeah, they go faster than the field, but they're still taking several months. We're finding good results in a 4 to 6 week window. So this is a picture of a friend of mine actually down in Georgia who was working with us on, she has some nematode problems, working with us on a sun hemp project. And this is her sun hemp just 25 days after planting. So she's in North Georgia. She just seeded this sun hemp with a Jang seeder right along the drip line, and that stuff just jumped. She ended up terminating it 9 days later, and she was like, I should have terminated the day you came out to take that picture, because it got away from her. She was able to get it down, but it took a lot longer for her to, she ended up, instead of being able to use her BCS, she had to go in and have to bush hog it and work it in. It took forever for it to break down, and she was really irritated at me for having her plant that and wait so long. So it's one of those things. Really want to have the plan for the termination method and timing in mind, and especially if you're getting started with a summer cover crop, they can grow way faster than the field if they have all the moisture they need and things like that. So if you're used to 30 to 45 day or 45 to 60 day cowpea or something like that, it could be 30 to 45 days inside the tunnel. It'd be quite a bit faster. So you got to keep an eye on it and get it when you can. And remember, you're wanting to also take into account the time it takes for that stuff to break down, because we don't want that cover crop, as it's breaking down, robbing any nutrients from your succeeding crop plant. Any questions about that? I'm kind of blasting through this pretty high level. Okay, just stop me at any time, okay? So with regards to soil organic matter management, the bottom line is it's challenging, right? We have a lot of competing economic factors. The cover crop research is emerging. It doesn't appear to be a quick fix. There's not one study that says, like, yes, this is definitively going to help your soil health. It's going to, help break disease cycles, build organic matter, yada yada. It's a long game, and it's variable, and but it appears that working it in when you can, as frequently as you can, and finding something that works for your system seems to be working for producers, and it needs to be done the overall organic matter management needs to be done in context of the whole management. When can you take time off? Realizing you want to be mindful of compost, but it might be an important tool in some situations, those kinds of things. Okay, so I'm going to switch gears and talk a little bit about nutrient management. And kind of the things that we've learned from producers around the country, problems that people are having universally, and then some really cool tools that are being used in other parts of the country that might be particularly useful for us here. Because although we have 1 billion tunnels going up in Kentucky, we are not on the front end of the technical assistance curve, in my opinion. It's something that we're working on, but there's some things that we can learn from other parts of the country. So what we found from talking to all these folks was that salt and fertility management are problems for everybody, regardless of where you are, whether it's a salt imbalance, which I'll talk about in a minute, or a total soluble salt problem. And in some cases, it was causing people to lose crops or lose a lot of their marketable crops, for example, on things like tomatoes. Folks had a lot of different kinds of strategies for managing salinity. The universal is we don't have great guidance for people on how to proactively manage salinity. We have some general guidance. We also don't have really great guidance for if you hit a wall and your tunnel gets really salty, the best strategies for mitigating that, tell you how much water to apply, those kinds of things. We have some general rules of thumb, so that's an area for research. Folks were pretty regularly testing their tunnels, soil testing, but the recommendations that were high tunnel specific are largely lacking. They're lacking here in Kentucky, at least at what we offer at UK. And even a lot of the private labs don't specifically recommend for tunnel crops. But there are parts of the country where they're starting to get on that in particular. And there's interest among soil testing lab directors around the country to better serve our tunnel producers. So it's a high priority for everybody. So let's just talk about why this is trickier than it is in the field. So I mentioned the irrigated desert problem. The other piece here is that when you cover that tunnel with basically a giant umbrella, we lose those leaching rains, which is great from a nutrient management perspective. We're not leaching nitrogen or nitrates into aquifers and things like that, but we also don't leach things like magnesium, which we take for granted. We never have to think about that in the open field, or at least not very much for most crops, and it creates some weird situations. We also, of course, have organic matter breaking down faster, and as you all know, we can get this really lush growth inside tunnels, and sometimes we pack them more full of plants, and so our growth rates can be a lot faster, plants can be a lot bigger than they are in the open field, so it can make nutrient deficiencies worse. So we think crops feed heavier in tunnels, so it can draw a lot more your nutrient levels down a lot faster. And the other thing that we take for granted is when we pull all of our crops out at the end of a growing season for disease management purposes, so they're not re-inoculating the next crop. Let's say your rotation is tomatoes, greens, and you're pulling all that stuff out, so your tomatoes and greens your next rounds don't get infected. That's all biomass that you're removing, so you're not putting that carbon back in, and you're not putting all the nutrients that are bound up in the biomass of those plants back in. So we're mining nutrients out of our soil at a much faster rate than what we typically see in the open field. I'm going to use the term salts, and I want to do a level set on what I mean by soil salinity and soil salt. So what I mean by that is any cation or anion in the soil. Okay, so I'm not just talking about sodium. I'm talking about other, for example, cations like magnesium and potassium, anions like nitrate, phosphates, sulfates, things like that. So anything with a positive or negative charge is technically called a salt, although we tend to think sodium, right? But to be perfectly honest with you, most of the time we end up with salt imbalances or total salt problems that are in no way related to sodium. They're not sodic issues, they're salinity issues. We don't often measure salts on a routine basis if you send a soil test into the university. Talk to the person that you're working with, whether it's your extension agent or something like that, and it can be really good to get an electrical conductivity test or a measure of your total salts, okay? So when we talk about salt buildup, a lot of times what we're talking about in tunnels is a buildup of total salt. But those imbalances can appear, and that cause you serious issues with crops like tomatoes, can appear long before you have a total salt problem. So this is, just to give you an example, this is a nutrient imbalance many of us are familiar with. What is it? Super common in tunnel tomatoes. Yeah. It's not calcium, but you are on track. Yeah. What's that? It's a potassium deficiency, that's right. Yeah, this is yellow shoulder disorder, and this and other ripening disorders some people think it's sun scald. And it can look like sun scald when it's not real bad and it's just around the top there. But you can see these ripening disorders. You'll know if it's a ripening disorder if you cut the fruit open and it's white on the inside. It's a potassium deficiency, and you can actually, so yellow shoulder disorder and a number of other ripening disorders are caused not by a total lack of potassium. Actually, your potassium levels can be fine. It's caused by an imbalance between the potassium and the magnesium. This guy named Tim Hartz discovered it, and he actually, well, maybe I'll save that story for a minute. But basically, he found that if you can bump your potassium levels above a certain ratio, you can at least reduce the risk of this problem. This is something that, especially for us organic producers, we really need to take care of on the front end. It needs to go down, potassium needs to go down pre-plant. And then it's really important to do, if you've had this problem in the past, to do tissue analysis at the first flower, okay? Because then you can use a soluble fertilizer like a potassium sulfate to try to top things back up. Once you have this problem, it gets worse over the course of of the season, okay? You can come back from it, but if you get it right pre-plant, it can be, that's really critical. There are other factors that weigh into fruit ripening disorders, but the single largest factor is the potassium to magnesium imbalance. Something that we don't typically see in the field. There's other strategies like cultivar selection and things like that that can help you get around it, but it's a really big one, and it's one of the first signs of a salt imbalance inside a high tunnel. Your total salt levels may be fine, your potassium levels may even be fine, but it's this imbalance between potassium and magnesium. Okay, so we're getting better at the university, at least figuring out how to help people flag this. I think we still have work to do on how to actually help people avoid it once it comes up. But so there's this calculator. It's called the Hartz ratio. There's a little calculator online, but if you are don't want to look it up yourself or having somebody help you, they can also just enter this into this Ohio State calculator. The other thing is if you get your soils tested at the University of Kentucky and you tell them that you're growing tomatoes, they'll get the Hartz ratio for you, and so it'll appear below your soil recommendations. So we can tell you if you're going to have a problem. Basically, what this is it tells you if you are above or below, or if you are at a low risk of potassium if your numbers are above a certain ratio. In this case, for our medium fine textured soils in central Kentucky, if you're above 0.35, then you're at low risk. So what if you are below that? Well, we just tell you that that you are at risk for yellow shoulder. We don't really tell you how much potassium to apply. Okay, we tell you to dump on 60 to 100 pounds per acre of potassium or potash before, or apply potassium nitrate if you're a conventional grower. We don't really tell you how far out of whack you are between your potassium and magnesium. Okay, nobody has done that research yet. It's obviously low-hanging fruit. Okay, but there are, in other parts of the country, they are treating potassium really differently. So we've learned a ton from the producers in New England, extension folks between University of Vermont, University of New Hampshire, and then a gentleman who runs University of Maine Soil Testing Lab. They've been pushing the envelope on yields in high tunnels, and particularly with tomatoes, for years and years and years. And what they were finding was they were not applying near enough potassium. And so they did a bunch of research up there where I put it, I'm just taking little snippets out here. If you're interested in the context of where this stuff is coming from, this QR code up here, if you have a cell phone, will bring you to the extension fact sheet that they have. So you can just hold your phone on that QR code, and it'll bring up the URL on there. I'm also happy to provide paper copies and things like that. I didn't bring any with me, but I'd be happy to send them down to you if you have an interest in where this came from, because they think about tunnel fertility really differently than we do. Okay, they're looking at fertility. They basically say, what's your yield goal? How hard are you going to push your soil? This is kind of where they are. They're really taking a greenhouse perspective. And are you looking at low, medium, good, or high yield? So of course we all want high yields, right? But again, you're pushing your soil really, really hard. So what they tend to recommend is somewhere in this medium range, which looks around 5 to 9 pounds per plant, pretty much. So it's still pretty good yield. And what I want to point out here is their recommendation rates are wildly different than what we recommend at the University of Kentucky. So what I'm just going to point out here, so they're calling a low result on your soil test less than 400 pounds per acre. We call low less than 200. What we call very high is above 450 pounds per acre. They're not saying you're way out of whack until you're over 1,200 pounds per acre on potassium. So their potassium, and this is based on doing a variety. They basically took greenhouse recommendations, tried them out and converted them from parts per million to pounds per acre, tried them out in tunnels, and looked at the yields. And so this is what their universities all around New England are actually recommending. They don't have the problem with yellow shoulder that we have because they tend to have low magnesium soils, okay? So we can't just take this across the board and say, we just need to dump more potassium on and then we're gonna be out of the woods. Our problem is a little bit more complicated, but we do know a clue to this is we are not pushing our plants potassium-wise as much as we can, okay? So this is a tip that we're learning from other parts of the country. That's kind of some best practices. So we're still working to refine these kinds of recommendations, but we know that, usually people don't recommend just dump on more, right? We have a tendency to do that sometimes, but we don't often recommend it from a university perspective. But if you're seeing low yields and a lot of yellow shoulder, it's worth maybe talking to somebody and potentially thinking about bumping that potassium a lot, okay? And then the other thing that I want to say just about high tunnel specific testing is that high tunnel soils change over time. And I pulled this, this is actually from the University of Maine's soil testing page. So they have a high tunnel soil testing program, and Bruce Hoskins, who's one of our project partners on this, has directed, he has a high tunnel on his farm as well, and basically super experienced looking at high tunnel soils from all over the country. And Bruce calls the first couple of years the honeymoon period. So basically you have a field soil, so it behaves like it does in the outside, and we put this umbrella over it, and you get the best of both worlds, right? You have the best of your nice fertile field soil, and you've got all the plant protection that a high tunnel affords. But then things start to change, and it depends on how you treat that soil, how it changes. It's extremely variable. Basically, once we get to about year 3, depending on how you've managed it, you can see really high levels of organic matter, really low levels. Depending on the crops that you've grown, really high levels of potassium, really low levels of potassium and phosphorus and things like that. So what they actually recommend is that if you have a really high organic matter soil, or your soil has been undercover for more than 5 years, they actually recommend that you test it like a greenhouse media. So you use a saturated media extract instead of our normal field soil test. And that's going to be more predictive of the nutrient release from that soil over the course of the year, okay? So that's something that we're starting to kind of get our arms around a little bit, as maybe we're not even using the right tests for tunnel soils. This isn't something that you have to send off to Maine to get run this way. If you take your soil sample and whoever you're working with, say, can you run it as a field soil, and can you also run it as a greenhouse media? Any soil testing lab has this capacity. They're not using it in this way. So these are tools that are out there in our toolbox that we don't always advocate to folks, but you can ask for them, and then you'll have this information in front of you as well. And they may also make recommendations differentially, more as a greenhouse crop recommendation rather than an open field. You with me? Okay. Soil fertility is not everybody's favorite thing, but it's super important, right? And there are definitely some things that we're learning. The other piece that we're learning, both from us and then a work out of New England, is that soluble nutrients aren't soluble if your soil's not wet. Right? If you've got the edge of the bed that's really dry, that fertilizer is just going to sit there in a dry chunk. So it has to. What we're learning is, usually in open field, we think about you just apply enough drip irrigation lines as you need to keep your crop growing, right? As you need to keep the crop wet or keep the soil wet in the root zone and keep the crop growing. Well, what we're finding is that for people to really avoid salt problems, you need to be wetting that entire bed. So 2 or 4 lines per bed, even if you only have 1 line of tomatoes in that bed. So you can keep that. It's super important for organic producers. It's not just a soluble nutrients thing, right? Because those microbes need moisture if they're going to be able to break down the fertilizers that we're applying. So we really need to rethink the way that we irrigate crops, not just as providing water to the crop plant, but providing water to the soil, to the microbes, so they can cycle those nutrients and then make it available. So it's an issue from basically making sure you're getting the fertilizer in the plant that you think you're getting, but it's also a really important salt management tool, because if you leave that fertilizer salt in the soil and it doesn't get mineralized, you can end up with different salt levels across the bed. I'm going to skip this part just for the sake of time. But the other thing that can happen is you can burn a plant. So what sometimes will happen is people will have a tomato and lettuce rotation, or they'll go early tomatoes, late cucumbers. And the tomatoes are thankfully not very sensitive to salts. So you may not see that you have a total salt problem, a salt buildup of some kind, until you put in a more sensitive crop right after it. So you got a hot spot of fertilizer because you didn't, the water wasn't on there. You plug a little lettuce plant in there or a cucumber late in the season, it's all of a sudden it starts showing tip burn and things like that. So it can create problems down the line if you're not mineralizing all those nutrients. So what do you do when you have the moment? Your soil's salty, you're trying to figure out what you can do with it. Well, what we found is it's a hard thing to come back from, actually. We're working on mitigation recommendations. How do you get these salts out? How can you irrigate them out? How can you leach them out? Those kinds of things. For sure, prevention appears to be the best practice, okay? So avoiding those salt problems in the first place. So if you can work in uncovered periods into your rotation. If you can, if you're changing your plastic every 4 years, a lot of folks were winter cover cropping. If you can winter cover crop and have that uncovered and then recover in the spring when your warm season crops are going in, get a few months of rainfall on there, at least every couple years, appears to be a best practice to help avoid salt buildup and help, like in this part of the country, might be helpful in pushing some of those magnesium salts down, so it can help with yellow shoulder and things like that. You can do movable tunnels. We don't see as much of a buildup of those issues. We do see potassium deficiencies in the normal stuff, but it's not nearly as bad as it is in our stationary tunnels. And then you can try leaching and flooding. We've done some experimentation with this where you just turn the sprinklers on and apply a foot of water. It's a lot of water, especially if you're on city water, you're paying for it. And what we actually find, so when we look at what Californians tell us to do from their fertilizer recommendations, they say, oh, if you just apply a foot of water, you're gonna push 80% of your salt below the rooting zone of your plant. We have not found that to be the case at all here, especially if you're doing it in the summertime when your water table, when your soil is bone dry all the way down in your tunnel, right? If you just turn on the water and add a foot, you've just wetted the top foot. You haven't pushed the salt anywhere. So it is a lot more complicated than what we tend to think about in terms of traditional salt mitigation and management. And we're really getting our arms around it. But there's not good guidance out there anywhere in the country for how to mitigate salt once you have it. So not to say you can't do it, but we don't want people to be out of production. You know, once your tunnel's up and running, you become dependent on it, right? For your markets and those kinds of things. And so we want people to be able to keep them in production. So if you can work some basic practices in there, cover crop some of the time, try to uncover it some of the time, you're at least trying to stay ahead of the game here a little bit. Okay, so the other piece here is irrigation management. Various strategies out there. I know on our research farm, a lot of the times it's Monday and Thursday is irrigation day, and that's what we do, right? So there's kind of the scheduling approach. Maybe we do some hand waving on about what the soil moisture level is and some things like that. But that is a difficult thing to get right year round and with different crop stages and things like that. So along with being careful with our water management in space, we also need to be thinking about it in terms of depth and in terms of frequency to keep nutrient cycling and to keep our crops growing. So what we're really trying to get folks to do, and really this has been the UK mantra for years, but there's some interesting new things with sensor technology and stuff like that, is to do soil moisture-based monitoring, okay? So in the open field, we often talk about, here we go, using tensiometers. How many people have used a tensiometer before? Okay, Hannah, awesome. They're kind of a pain, to be honest with you. So basically, they have a little clay cap on the bottom end here. They cost about $50, but you can use them forever. You stick them in the soil at your plant's rooting depth, and then you take a soil and water, slurry together. You pour it down the hole. It creates a little cap, and then the conductivity across that little cap basically pulls a vacuum, and I guess it's the suction pulls a vacuum, and then you can figure out what the water potential is in there. These are great during the main season. You cannot use them when it freezes. So for those of us that are doing year-round growing, this is really not helpful. There's kind of a digital version of this that's not crazy expensive. It's called a watermark sensor. You can see it down here. It's basically that little clay cap inside a little sensor, and you can plug in. The sensor costs like $35. The handheld unit costs about $200. So it's kind of high, but you can plug these little guys in all over the place. And there's good guides for helping you figure out, based on your soil type and the depth, how much water to apply. And then you'll know that you're beyond just eyeballing what your ideal soil moisture is. And then tons and tons of stuff in this constantly evolving space around sensors. So if you are off the farm, for example, and you're trying to figure out whether somebody should turn the water on or something like that, there's lots of weather stations and things like that that run anywhere from $500 on up that can link to apps on your phone if that works for you, and things like that. So lots and lots of options. Bottom line here is consistent water management, which also equals consistent fertility management, is keeping an eye on the soil moisture levels, ideally through knowing exactly what's going on in the soil is the way to go, okay? Because it has cascading effects, not just for the crop. We tend to think about just irrigating for the crop, but in tunnels especially, we have to be irrigating for nutrient management. Okay, so there's a ton about water in high tunnels that we do not know, okay? And so this is kind of the what producers are telling us, as well as areas of research that we need to figure out. So what is the role of those really long dry downs? So you don't grow you pull out your tomato crop in the summertime, soil's dry as a bone, and you just leave it until you're gonna plant your lettuce or whatever 2 months later. Probably not stoked if you're an earthworm, right? Or a microbe or something like that. Stuff is just dry as a bone. We don't really have a good handle on what's going on there from a soil organism and soil process perspective. And then what happens when we wet it back up? How resilient are those soils in popping back? Is that part of the reason that we see things really change after a few years? Is it linked to some of these really extended dry down events? What's the right regime, irrigation regime to balance crop quality with nutrient management? Things like that. And then how the heck do we deal with salts once they become a problem with irrigation so that you don't have to take 3 months out of production when you're changing plastic and you can flood it out in a couple of days, let things dry out and get back in there. So that is something that we don't know. And I only bring this up because would help you with it if we could, but we don't have that information out there. So just kind of in summary, soil testing is really the linchpin to this, right? To at least get a baseline of what's going on. A lot of people ask, how often should I soil test? Once a year is probably enough for most of the things that a standard soil test measures. But we recommend you take that before your most important crop, which usually is a warm season crop like tomatoes that are going in early or something like that, or at least your most nutrient demanding crop, okay? And you might think about whether you need a saturated media extract test if you have soil organic matter or a lot of fertility or your soil's been under cover for more than 5 years or something. The other piece that I didn't talk about, but that's pretty important, is we think about soil tests as something that you got to get right, and then you kind of cross your fingers and hope your plants do okay. Well, your plants can tell you how they're doing. You can just ask them. Take a foliar test, right? So take a nutrient test at things like tomatoes. It's going to be at first flower is a really critical time to do that. We don't offer that at universities, but lots and lots of private testing labs do. They're not super expensive. They're like 10 or 15 bucks. Some people, large-scale commercial growers, this is just a standard part of their rotation, or part of their management practice is taking those tests. And salt imbalances and accumulation only get worse over time, okay? So we know that some of these it's probably the many little hammers approach, right? So many small taps to try to kind of keep things in line is what we're finding tends to work for people who maintain healthy high tunnel soils over time. It's not any one set of practices, but we know that cover crops, diversified crop rotations, and letting it rain in there when you can seems to be an important piece here. Okay, so that is all that I have. Want to thank a bunch of folks and tons of colleagues and farmers and folks that provided input on this. The other thing that I didn't mention at the outset when I talked about our tunnel setup at the UK farm is that it was funded by a Kentucky Department of Agriculture Specialty Crop Block Grant 10 plus years ago, and they made a really nice investment in us that has paid off, and so we wanted to thank them for that. All right, questions? Best time to take a leaf sample. Depends on the crop. Do you have a crop in mind? Oh, what time of the day? That's a good question. I'd say mid-morning, probably. It depends on what you're looking for. If you're looking for things like, so plants tend to, some plants tend to accumulate nitrates in the night. And then once their photosynthetic machinery warms up, they start processing that through. So you may get an artificially high nitrogen level if you take that sample in the middle of a cool morning. I would probably take it mid-morning to afternoon, then you know that stuff is kind of cranked through. It doesn't matter if the plant wilts or anything like that. They're just going to burn it up anyway, so it doesn't really matter. But I wouldn't do it very, very first thing in the morning, especially on things like leafy greens and stuff. They tend to accumulate luxury nitrates overnight. What else? All right. Well, I'll stick around. I don't want to get between folks getting home before the storm hits and whatever, but I'm happy to stick around if anybody has any questions.